All right, guys. So last time we talked about using a heat transfer equation. In other words, figuring out how much heat something had gained or lost based on a temperature change. Okay. Today we're going to use that in a more practical sense. We're gonna cover a technique that is used kind of all over without you even knowing it exists. This is how they figure out how much energy or calories are in your food and stuff like that. Okay. The topic we are covering today is something called calorimetry. Okay. Basically, calorimetry is just a method of figuring out heat transfer for one object based on what happens to another. Okay, so basically, what a calorimeter is, okay, a calorimeter is a device that is like airtight. Okay, it's so no heat can come in, no heat can go out. Okay, it is a heat-tight container. All right, and in this container, most of the time you have a specific amount of water. Okay, so what you do is you take an object that is at a certain temperature, you drop it in the water, okay, and then you measure the water's temperature change. Okay, based on the water's temperature change and how much water there is, you can figure out the heat that was either gained or lost by the water. All right, now, real quick, the Q for the water, okay, is some number. Okay, who cares what it is? But this number, if this is a heat-tight container, okay, if this amount was gained by water, that means that whatever was put into the water lost all that heat. Okay, so if this is true, then the Q of the other object is going to be negative that number. Okay, so it'll be the exact same value, just with the opposite sign, because what happens to one, the opposite has to happen to the other. Okay, that's kind of the whole premise of this. Okay, this is also a method of figuring out specific heats for objects that you don't actually know ahead of time. Okay, that being said, I'm going to give you guys an example for kind of a situation where this could work. Okay, and a bunch of different parts of problems that I could potentially ask you. Okay, so Okay, so this is a giant problem, okay? And unfortunately, calorimetry problems are all going to be this long. Okay, they just are. Which means it's critically important that you understand how to pick out important pieces of information and roll with kind of ignoring everything else. Okay, so real quick, all right, you have two objects here. Okay, and you're going to need to do Q equals MC delta T for both of them at some point. So we need to kind of identify what each number and each piece of information is in terms of variable and figure out which substance it belongs to. In this case, it's either going to be the water in this problem or the iron. Okay. The question says a 380 degrees Celsius ball of iron was dropped into 300 milliliters of water at 25 degrees Celsius. Okay. After some time, both the ball and water reached a final temperature of 85. Assuming no heat entered or was removed from the container, A, how much heat was gained by the water, B, how much heat was lost by the iron ball, and C, what's the specific heat of the iron. Okay, so let's go ahead and start kind of labeling some stuff here. Okay, so if we need to do Q equals MC delta T for two different substances here, okay, we're going to do it for the water and for the iron. Okay, we should probably label some stuff out. Okay, so this is going to be for water, and this is going to be for iron. Okay, so at this point, okay, the Q for water, okay, how much heat for water do we have? Okay, that's what it's asking for in part A. You're probably not going to know that. Okay. M, the mass of water. You aren't explicitly given it, but you're given milliliters. Okay. Remember, density for water is 1 gram for 1 milliliter. So if you have 300 milliliters, that means you have 300 grams of water. All right. The C for water is a constant. It's in your reference packet. You used it a bunch yesterday. It's 4.18 joules per gram times degrees Celsius. And then delta T. Okay. First of all, you need to identify your starting temperature for water and your ending temperature for water. Okay. The 25 is your starting temperature. Okay. However, it says after some time, both the ball and water reached 85. So this is your final temperature. Okay. If change in temperature is final minus start, it's 85 minus 25, and that should give you 60. Okay? So, that's all the information we have for water right now. So let's go ahead and look at the iron ball. Okay? According to this problem, okay, part B says how much heat was lost by the iron. So technically, we don't know that. Not yet. Okay. The mass of the iron ball. Okay. Technically, this one's on me. I should have written it in the problem. So I'm gonna kind of put that up there. Okay. So with the addition of that little piece up there, that the ball of iron weighing 20 grams was dropped in there. Okay, so mass is 20. Okay. The specific heat of iron is what's asked for in part C, so technically we don't know that yet. And then your delta T for iron. Okay, your starting temperature for iron is going to be that 380. It says a 380 degrees Celsius ball of iron was dropped. Okay, then it drops to 85 because it says both the ball and the water reach that temperature. Okay, so if 85 is your final temperature and 380 is your starting temperature, okay, it's going to be 85 minus that. It's going to be negative because you have lost heat. Okay, so in that regard, I believe it should be what, 295? Negative 295? Okay. Either way, we have all the information that we can have right now, so let's go ahead and try to solve part A. Okay. Part A is asking you how much heat was gained by the water. Okay. So all we need to do is take a look at the water side of things there. Okay. And just solve for Q. That's all it's asking for. Heat for water is Q for water. Okay. And thankfully, we have all the information there we need in order to find it, so let's go ahead and solve for it. Sorry about the camera. There we go. All right, so this is for part A. Q equals MC delta T. Again, we're finding Q. So Q equals our mass of 300 times C of 4.18 times your delta T of 60. All right. Multiply all that mess together and you should get your answer. I forgot my calculator in the other room, so give me just a second. All right, my apologies. Okay, when you multiply all three of those together, you should get 75,240. Okay, since this is heat, since it's energy, again, Q is always measured in joules. All right, so that's going to be your answer to part A. Part B, how much heat was lost by the iron ball? Okay, so remember, just like we talked about at the beginning of this video, however much heat was gained by water has to be lost by the other thing. They're going to be the exact same number, only the one in part A is positive because the water gained heat. The one in part B is negative because you lost that heat. Okay. Okay. And again, this is for water. This is for iron. Okay. Whichever one is positive, the other one's going to be negative. All right. In the next video, we're going to solve for part C, and then that should be it.